Hi guys, so today we're going to be talking about tangents. Okay, this is different from your tangent where it's opposite over adjacent. This means something different. Okay. So here, it uses this example of a circle here and then this ray BC. Okay. So here it says ray BC is tangent to circle A because the line that contains BC intersects the circle in only one point. And so that's what tangent means. Tangent means there's a line that is tangent if it only touches your thing, your figure, whatever, in one point only. Okay? This point in which it touches is known as the point of tangency. There you go. So here, starting with our first theorem about tangent lines, is if a line is tangent to a circle, so here line RT is tangent to circle O, then what it is it is perpendicular to the radius drawn to the point of tangency. So that means line RT is perpendicular to radius OR. Okay? And with that in mind, we're going to start with example 1. Okay. So here, ED is tangent to circle F, okay? Which as a result, we know that DE and EF are going to be perpendicular, right? And then here it asks us to find X, okay? So since this now forms a right triangle, I can use Pythagorean theorem to solve it. So 3 squared plus 4 squared equals my hypotenuse, which in this case is X squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and so then when I square root both sides, it should be plus n minus 5, but since here we're talking about distance and we can't have negative distance, so x equals 5, and there you go. Right. So why don't you try CYP 1b, and then once you're done, come check your answer. Okay, you should have gotten that x equals square root of 93, which is approximately 9.64. Exact answer, approximate answer. Okay, if you got that right, you can move on to example 2. If not, here is your explanation. Okay, so here BC is tangent to circle A at point C. So that means then this radius and this tangent line is perpendicular. So this forms a right triangle, with this being the hypotenuse. And so x squared plus 14 squared should equal my hypotenuse squared. 14 squared, 196. 17 squared, 289. Subtract 196 on both sides, that's 93. Square root both sides, x equals square root of 93. Right. Okay, then, before you move on to example 2, we can also know the converse of the previous theorem. So before it was if it was tangent, then it was perpendicular. So this time it's flipped. This time if the line is perpendicular to the radius of a circle at the end point on the circle, then that line is tangent. So this is the converse of the previous theorem. Okay? So we're going to use that to now determine whether line MN here is tangent to L, okay, and justify your reasoning. Okay, so here LM is 3, MN is 4. This 2 here is only ON. So what is LO? Okay, well you should recognize that LO here is a radius. So if this LM is also a radius, it should be the same. So this should be 3. Which would make this a total of 5, okay? And we're here to see, is this a right angle? Because if it is, it would be tangent. So, does 3 squared plus 4 squared equal 5 squared, okay? Hopefully you recognize this as a Pythagorean triple and you would know, but if you didn't, right? Does 25 equal 25? Yes, it is. So that means MN is tangent because it is perpendicular to LM. and that is y. Okay. So let's try this next one. Okay, we're going to determine whether PQ here is tangent to the circle. Okay, so QR I know is 4, QP is 5, SP is 4, QS is another radius, so if this radius is 4, this should be 4 too, for a total of 8. Okay. Is this a right angle? Let's see. Does 4 square plus 5 square, does it equal our 8 square? Okay. 4 square 16, 5 square 25, 8 square 64. 16 plus 25 is 41. 41 does not equal 64, and so PQ is not a tangent. And the reason why is because PQ is not perpendicular to, in this case, RQ. There you go. Okay. So why don't you try CYP2A, and then once you got your answer, come and check. Okay, you should have gotten that GH is not tangent to the circle. The reason why is because GH is not perpendicular to FG. That 100 does not equal 324. Okay. If you got that right, you can move on to our next example. If not, here is your explanation. Right. So again, we're seeing, are these perpendicular? Right. If so, it should meet the Pythagorean theorem. Right. That 8 square plus 6 square should equal this 18 squared. Right. Because h to here is 12, so here to here, this is 6, because this is also a radius, okay, for a total of 18, and it doesn't work. 100 does not equal 324, and so that's why they're not tangent. They're not perpendicular. The Pythagorean theorem didn't work for this. Okay. Before we get on to example 3, let's talk about our next theorem. Okay. So here, if two segments from the same exterior point, so note here A is exterior, right, because it's outside of my circle. If here two segments that go to the same exterior point, if these are tangent, so if AB is tangent to the circle and if AC is tangent to the circle, what we know is that AB and AC are congruent. They are equidistant. Okay? So that takes us to X. Okay? To example 3, sorry. Okay, so here we want to find x. Okay, assume that if it looks tangent, they are tangent. Okay, so here, what you should notice is that in this circle, right, this line and this line are tangent. Right, only touches the circle in one spot, even if it goes on forever. And so, based off of that, I know that this and this is congruent. Okay. Then, looking at this circle, okay, note then that these two lines are tangent to the circle Q, and they also meet out here at A, and so what that means is that this segment and this segment would be congruent. And as a result, if this is congruent to this, and this is congruent to this, right, then, like our transitive property, we know that these two are equal to each other. Okay, and so that would mean that negative 2x plus 37 here will equal our 6x plus 5. Okay, so I'm going to add 2x to both sides, so that will give me 37 equals 8x plus 5. Subtract 5 on both sides, so that means 32 equals 8x. Divide by 8 on both sides, that means x equals 4. And there you go. Okay. So why don't you try CYP3 and then come check my answer when you're done. Okay, you should have gotten x equals 11 and y equals 1. If you got that right, you can move on to our last example. If not, here is your explanation, right? So again, if tangent lines intersect or meet at an outside point, okay, those segments are congruent, right? So here, these two tangent lines meet at point M. So that's why these are congruent. So that's why 2x minus 3 equals 19. Okay? Here, these two tangent lines meet at R, and so 3y plus 5 and 2y plus 6 would also be equal. Okay? Add 3 on both sides, that gives me 2x equals 22. Divide by 2 on both sides, that gives me x equals 11. Okay. Subtract 2y on both sides, that gives me y plus 5 equals 6. Subtract 5 on both sides, that gives me y equals 1. Okay. And then we're now moving on to our last example, which is circumscribed triangles. Okay, so again, polygons that are circumscribed, they should be touching. Okay? So note that this polygon is circumscribed because it touches the circle on each side. Touches it on each side. Okay, this is not because it doesn't touch this side, and this is not because part of it is outside. Okay, so it needs to touch each side. Okay? So here, triangle ADC is circumscribed around circle 0. We want to find the perimeter of the triangle. Okay, and so one thing we know is that EC is the same as DE plus AF. Okay, so here, with this circumscribed triangle, okay, note that these are tangent lines, and here they touch at D, so that means ED and DF are the same. So these are congruent, so since this is 6, this is 6 as well. Okay. Same thing with here, right? So note that these tangent lines, this touches at A and this touches at A, so BA is 19, FA is also 19. Okay? And then with the idea that EC equals DE plus AF, DE is 6, right? We just talked about that there. And AF is 19. So 6 plus 19 is 25. So EC here is 25. Okay. And then here, if we look at these tangent lines, they intersect here at C. So that would make EC congruent to CB. So this would also be 25. And to find the perimeter of the triangle now, we have every side. So that will be 25 plus 6 again, plus 19, plus this 19, plus 25. Okay? And then let's enter that all in. 25 plus 6 plus 6 plus 19 plus 19 plus 25. And that gives me 100. Okay? And so the perimeter of this triangle is 100 units. Okay? So why don't you try CYP4, and then once you're done, come check your answer. Okay, you should have gotten that x equals 4 and that the perimeter is 52 units. If you got that right, you can get started on your homework. If not, here is your explanation. Okay? So triangle JKL is circumscribed about circle R. Okay? So then here, if you look, MK and NK intercept at K, and these are both tangent, so since this is 7, this is 7 as well. Okay? Same thing goes with MJ and OJ. Okay? They're tangent, they intersect at J, so that's why they're both equal, so this is 12, this is 12 as well. Okay? Same thing goes for this NL and OL, so that means this x plus 3 and this 4x minus 9 should equal each other. So then I set them to equal to each other to solve. Subtract x on both sides. That's how I get the 3x. Add 9 to the other side. Add 9 to both sides, and that's how you get 12. Divide by 3 on both sides, you get x equals 4. I plugged it back in, and then I got 7 and 7, which works. So now I have everything. So it's 7, 7, 7, 7, 12, 12. Add them all up, and you get 52 units. So that's it for today. Have a great rest of the day. Bye, guys.